Null pointer exception is the runtime exception, which we saw that if you haven't initialized your hash map and if you try to put something into it, you would get null pointer exception. So you have to make sure that you instantiate the map first and then start using it. Unsupported operation exception. This occurs when an attempt is made to change a map which is unmodifiable. So you can get an unmodifiable version of a map, and if you try to change something within it, this is what you are going to get, unsupported operation. Hash map, linked hash map, and tree map. So this is pretty much similar to the examples that we saw for the set, right? Java hash map class implements the map interface by using hash tables. It inherits abstract map and implements map interface. It contains only unique elements. Hash map contains values based on the key. It may have multiple null values, but only one null key. So this is important to note. You can have multiple null values, but only one null key. You can't have multiple null keys. So null is also treated as a key, as a valid key when it comes to hash map. Right? Whereas in hash table, there's one more variant of key value pair, which is hash table, which would throw you an error if you have key as null. But hash map takes key as null. So that's an advantage of it. So hash map doesn't maintain the order of the element. Linked hash map maintains the order of the elements in which they were entered. And tree map sorts based on the key. So these are pretty much the same thing that we discussed for map earlier. If you see entry set, key set, and all those things, we have already discussed about, and it's the same one. This is something that we have in specific to tree map. You could get first key, you could get last key. All right, since it is sorted, you could get it. Now there's a hash map example. I create a main method first. Then I create private map and then create hash map. And I create a new map here, say map of integer string. Typically you would have integer as your ID, right? Say employee map, all right? And which would be new. Suppose I create a new hash map. All right, so I'm creating a new map here, which is like the key would be integer, your value would be string. Dot put is a method that we use, and say employee map dot put. All right, so this is how you put into map. All right, so I've written this map from here. So we'll take an example of hash map wherein we would be putting some ID and we would be putting some value as a string, and we would check how it gets iterated or how we can iterate through or get something out of the set, out of the map. Okay, so here you can see that I created a hash map. I created this method which is create hash map, and I put some value within, which is nothing but, and you could see here it's a map of integer and string. So I put a value of 1 and I put value as x, I put 2 and value as y, and I put 100 and value as a, right? So I created a map of employee ID and employee name, so to say, right? Okay, so I've created this. And so what we are going to do here is, so you could even print out a map directly if you want. If I print it out like this, like map to print, you would see all the values contained within the map. All right, so this is, all right, I print the hash map right here. So basically I created demo dot create hash map. Okay, demo dot print map, and let's print this map here. All right, so we have inserted 3 entries into this map, 1, 2, and 100 with ID 1, 2, and 100, and which has got value of X, Y, and A respectively. And what we are doing is we are just printing the map, contents of the map right here. So you could see here there's 1, 2, and 100 been printed out here. All right. So again, this is a hash map, and you could have It's based on hashing, so it doesn't maintain any order. So if you have multiple values within, you would see that the order is not maintained, similar to what we had in hash map. So if I put something like this, all right, now when I run it, you would see that insertion order is not being maintained, and when you retrieve it, you will get it in any order. All right, here we can see that the order is not been maintained. 112 is displayed first, which is second last actually. All right, so it gives you all the entries within the map, but it won't maintain the insertion order. So that's, if you want to maintain the insertion order, you have used linked hash map. All right, if I change this to linked map, linked hash map, so just one single change would, so I copy the same stuff here. All right, and I put a linked hash map. All right, and suppose I create one more, which is for tree map. All right, so we have created three maps here. One is your tree map. So the other one is linked hash map. Linked hash map. Now let's print one by one. Right, the first one is hash map that's already been printed here. Now I create linked hash map. All right, and the third one that I print is demo.create tree map. All right, so we have all the three maps created and we are printing it here. All right, so here you could see that when it comes to hash map, the key value pair is not maintained, right? Whereas when it comes to linked hash map, this is a linked hash map and you could see that the order is exactly the same as the order in which we put in. All right. And when it comes to tree map, which is the third one, and here you can see that it's sorted one. So sorted by your key, not the value. All right, so see the key to the left hand side. When it says 1 equal to x, 1 is the key and x is the value. If you see it, you will see that 1, 2, 11, 21, 100, 111, 112, 1010, and 1100. So you could see that it's been sorted per the key. All right, so there's enum map. Enum map is a specialized map implementation for enum keys, all right, which we saw. Here we can see that there's a enum, which is nothing but constants, and you could see three constants being put into the months, which is Jan, Feb, and March. And you could see there's a enum map created for all the months or for all the months that you have within your enum, that is months, all right. You have this enum map and you could actually put in values something like this. So basically enum map is nothing but you could use the enums or the values within the enums as your keys, all right, when you use enum maps. And you could just iterate through it to see that you have these keys put in and values put in properly. All right, so just to give you an example, we can create a enum here. I'll choose to create the same one and I create enum here, right? So I create enum month and which has got, say, for example, Jan, Feb, March. All right, so we have created this. Now what I do is I create a new enum map with months and with string as its value. So I create a main enum map with month and maybe could put integer as. I create this enum map here. All right, enum map of you have month and integer. All right, so here we will have to give a month dot, or even month is okay, takes class, so month dot class. All right, so in the constructor we could see that it takes class as a parameter, so we put month dot class as a parameter. Now I put map dot put, I put like the key is your, it is depicting something like sales done per month. All right, it basically it refrains you from putting anything but the enum value as your key. All right, so that's what we are trying to do here. And you could just print enum map calendar and you should be able to see the values. All right, so it's basically restricting the key as one of the values or one of the constants declared within your enum. So yeah, you can see here Jan is equal to 100, Feb is equal to 200. You could. Now I'll quickly talk about comparable and comparator. Comparable and comparator are the two interfaces, or it's used when you want to have sorted set, or if you want to sort a collection. Say for example, you have list of integer and you want to sort it. A list of integer is something that is by default could be done because integer itself implements comparator. But if you have a self-defined class, or if you have your own class, say for example, if you have your own defined class, something like this, vehicle info, which has like a number of wheels, mileage, and name of the vehicle put in. Now, if you want to sort this particular class, if you give it to a sorter, it won't understand because this is a self-defined class, right? It won't understand what you want to sort in this, right? Basically, when you have something of this sort, when you have your own defined class and you want to sort it, that's when you use comparable and comparator. All right, so I'll just walk you through it. So comparable interface is used to sort the objects of user defined class in an order. So to give you an example, suppose you have an employee class which has got ID and say salary, right? If you want to sort it by default, Java wouldn't know what you want to sort within that particular class, right? You want to sort it by the identifier or the ID field within the employee. Or if that's the use case, then it could be like you want to understand the order in which employees joined the company. And the other case could you want to sort it by salary to understand which employee is taking the most salary, or to understand the sequence in which salary is being paid to the employees, right? So to make Java understand which use case you are trying to solve based on which identifier or based on which property or instance variable within your class you want to sort, to just indicate Java that this is what we want to do, express it in the form of implementing comparable interface. It is in java.lang package and it contains only one method, that is compare to. It provides single sorting sequence only, that is you can sort the elements based on one data only. You can't have multiple data, can't sort based on multiple data. All right. So I'll just walk you through this, which would give you an example. So basically you have a student which implements comparable. Now here you could relate to the example that I took, wherein you have roll number and name. Now you want to sort it. Now what we are trying to sort here is by roll number. So that's how you express using comparable, right? You have comparable student, right? And you could see here there's a compare to method that this comparable student has got, or the comparable interface has got. Now compare to will take student as a parameter. All right. Now you could see that we are comparing roll number, right? You're comparing the roll number of the parameter student that's been passed to the compare to. If it is equal, then it's zero, right? You don't have to do anything. If it is greater, then you return as one. And if it is less, then you return as -1. So basically based on this compare to, Java will do sorting. All right. It will sort it based on whatever you provide here. So what you're trying to tell Java is if it is equal, we are returning 0. So this is a contract. Okay. This is what we need to actually, this is how it's been coded, or this is a contract that you need to follow whenever you compare to. So if it's a roll number, then you say it's roll number 0 or return 0 if both the roll numbers match. If the one in your instance is greater than the one being passed here, then it would return 1 or else -1. All right, so how do we use this? So basically you can see here you created student. All right, so there were like 3 students created, 101, 103, and 102. You could see 3 IDs being created here. All right, now what you're doing here is collections.sort, and you are passing your array list of student, and you use collections.sort. All right, when you do collections.sort, what it would do is it would arrange it, or it would sort the array in the order of roll number. So 101 would be first, 102 would be second, and 103 would be the last. All right, so there's comparable and there's comparator. All right, there are two interfaces. Comparator is nothing but it is used to order the object of use. Again, it is used to order the object of user defined class. But what is different in comparable is comparable takes compare to, which takes just one parameter as input, and the other parameter is nothing but the instance within the class itself. All right, or this instance rather, the instance on which this particular method or instance on which compare to method was called. All right, so basically comparable will have only one method compared to. All right, whereas comparator, when you use comparator interface, it will take two methods, or it will take two parameters in the compare method. All right, and it will compare both the parameters that are passed. So basically it's for customized sorting. In the first example, that is comparable, we are putting the logic of comparing within the class itself, but you have a separate class which implements this particular comparison logic. So basically you could see here, right? You have a class student, and student is just holding the values of roll number, name. All right. You don't see how you don't see the comparison logic within. Now you have another class which is name comparator, which implements comparator. All right. There's name comparator which implements comparator. Now if you see the compare method, it takes two parameters. The earlier one, the compare to method in comparable, was taking just one parameter. Here it is taking two parameters, right? And what you could do is you could simply compare based on name, right? Since name is a string, you could do s1.name.compare to s2.name. This would compare based on name. There's another one. You could have one more class created, which is nothing but roll number comparator, which implements again comparator. Now here you would use the same logic that you defined earlier for roll number. All right, if s1 dot roll number is equal to s2 dot roll number, return 0. Else if s1 dot roll number is greater than s2 dot roll number, return 1. Or else if it is less, if s1 dot roll number is less than s2 dot roll number, return -1. So based on this logic, you would see that the compare, or you would see the sorting happening. Now, how do we use this? So we have defined a class, we have defined a model class. So model class is nothing but a class that has got just the state, right? Student, if you see, student doesn't have any behavior as such. It doesn't have any method within. It is just a state. So this is a model class, all right? So student is a model class which has got roll number and name. And we have two separate comparators defined here, name comparator, which is comparing the name, and we have a roll number comparator, which is comparing based on roll number. All right. Now, how do we use it? This is not sorting it yet, right? How do we use it? So how do you use it is nothing but you have collections dot sort. All right. This is pretty much similar to if you see the other part of the program. This is just about putting the data into your class. All right. So you have 101 put in as Vijay, 106 put in as Ajay, 105 put in as Jay. All right. And now we are trying to sort this based on roll number as well as name. So both these can't happen in one go, by the way. All right. This is like first you can have something done on roll number, and so it's not in one go. All right. You could do it in stepwise manner. So as you could see here, how are we using this comparator is nothing but you have collections dot sort, and then comes the collection that you want to sort. In this case, it is AL2. All right. And then you provide the comparator. So here you are providing new name comparator. All right. So after this particular statement is called, you would see that the collection has been sorted based on name. All right. And the first one here, as you could see, collections.sort AL2, and here you are passing roll number comparator. In the first statement, or here the first collections.sort statement would sort based on roll number, whereas the lower one would sort based on name. All right. So this is basically offloading or just decoupling your comparison logic out of your class. That's when you would go with comparator. Whereas you would go with comparable when you want to put the logic within the class itself. All right. So it depends on what use case you want to do. But as far as the performance is concerned, it's pretty much the same. All right. Even if you use comparable or comparator, it's pretty much the same. It just depends on how you want to write. It's a programmer's wish. So few people prefer to have modular programming rather than coupling everything into one class. They would go with comparator, and few people like to add things to the class itself, which they would go with comparable. So what is comparator and comparable? Comparator provides single sorting sequence, that is, we can sort the collection on the basis of single statement such as ID or name. As we saw that you would have just one compare to method, and based on that you would have the sequencing done or the sorting done. Whereas comparator, you could have multiple logics. Since you could have multiple classes implementing this comparator, and you could write your own logic. Like in the previous example, we saw that we had a comparator based on roll number and we had a comparator based on name as well. Comparable affects the original class. Comparator does not affect the original class. So we saw the student class, right? The student class, within the student class itself, you defined the compare to method when you used comparable. Whereas when you used comparator, you wrote different classes. So that's about decoupling that I mentioned. Comparable provides compare to method to sort the elements, and comparator provides compare method to sort elements. All right. Comparable is found in java.lang package, and comparator is found in java.util package. We can sort the list of comparable type by collections.sort list, and we can sort list of elements of comparator type by collections.sort list, comma comparator method. All right. When I say list, it's a list of some type, right? So in the previous case, it was list of student, and since student class itself had the logic for comparison, we don't have to mention it explicitly. It's taken care of by itself. Whereas in this case, wherein you used comparator and you had different classes wherein you put the comparison logic, in that case, you have to explicitly give the comparator, right? Like we gave something for roll number, we instantiated roll number comparator and gave it for sorting by roll number, and we instantiated name comparator for sorting by name. All right, so that's how we sort user defined classes. So basically, why do we have comparable and comparator? Just to reiterate, but JVM or Java wouldn't know how to sort a user defined class, right? It could be based on roll number, it could be based on name, so it won't know by itself what you're trying to do. So that's how you, using these interfaces, you express your logic of comparison.
So what is XML? So Henry handles the database of a college, but the data is stored in a form of XML file. He wants to extract information from this. Now he is learning XML so that he can handle it easily. So what is XML all about? It's an extensible markup language. It is designed to store and transport data. XML has hierarchical human readable format. XML is platform independent and language independent. Why did XML come into picture at the first place? So it's basically you have different systems. Tomorrow you might develop some system or you might have some service that is exposed to the outside world. So what happens is there has to be some contract. You as a client or you as a service provider, first of all, would expose a contract saying that if you give input to my service in so and so format, I'll give you output in so and so format. So basically, when you want to send data from a client to the service, you would send it in a specific format that the client understands or the server understands. So the server exposes or the server expresses the input format in a XML form. And this is platform independent. This is like you might have a service tomorrow in created in .NET, which can use the same XML as used by Java program as well. So it's a platform independent thing. Basically, it's used for carrying data, as I said, store and transport of data, which we'll see in the coming slides. But you could imagine this as nothing but a file which is used to send data from your client to the server for communication. It's pretty much human readable. It's not like yesterday we saw about serializing the state of the object, which was not human readable. So this one is pretty much human readable. You could imagine like you would have an employee ID, or if you want to search something in the employee directory and there's a service which is exposed for that, you could imagine that you could send an ID to it, or you could send an employee name to it, and format in which it is sent would be pretty much human readable. You could see that, okay, there's an ID, there's a name which is sent to the server, and the server is doing so and so things. So it's hierarchical and it's pretty much human readable. Again, as I mentioned, it's platform independent and language independent. It's agnostic of all these technologies. So there are a lot of existing services which use XMLs as a part of input data and output data. So as we go through the examples, you should be clear to you guys about what XML is all about. Why we need XML? XML is an industry standard for delivering content on the internet. So it's a standard. So most of the services, most of data intercommunication that's happening within internet is done in the form of XML. They communicate with each other in the form of XML. XML is designed to store and transport data. XML is extensible because it provides a facility to define new tags. It's not that once you define it, it's all done. So it's extensible. It's extensibility feature wherein I can say today my server is accepting employee ID and employee name. Tomorrow my server want to accept employee salary as well. So you could add that to it, add tags to it, which makes it extensible. So it's not one time defined. You could change it. You could evolve the XMLs. XML is used to describe the content and structure of data in a document. So it has got its own schema, and you can say that my XML is going to contain just email ID and employee name, nothing else. And you could validate real XML or the actual XML that you have against this schema. And if you have some extra parameters put in, it would throw you an error. So that's about why you need XML. Let's talk about what are the features of XML. Why is it so widely used? Writing XML is pretty much easy. As I said, it's human readable and you could actually write it. And there's a lot of API or a lot of SDKs that are exposed for reading and writing with XMLs, and very optimized version of it. So you could see parsers, right? We had multiple parsers. It's for performance based on the needs of your particular application or the nature of your application. You would select one of the parsers. So writing XMLs is very easy. The other one is XML data can be extended with DTD and XSD. It's a schema description. As I said, you could extend it. It's not that it's one time defined. You could extend it. XML can work on any platform. There's platform agnostic. You could run it on any platform, either .NET, or it could be different languages or different platform. It could be different operating systems as well. I could run it on Linux tomorrow, or I could run it on .NET. Any tool can open XML file and can parse it in programming language. So a simple editor, even Notepad, you could open it in Notepad++ and just view through it. And there are different tools available in the market as well, which would give you kind of format your XMLs so that it's much more readable. So there are a lot of tools available already. XML separates data from HTML. It separates the actual data from HTML code. XML simplifies data sharing. So basically, as I said, it pretty much intercommunication standard between systems. You just have to put it into XML and you share it across systems. XML simplifies data transport. What is the difference between XML and HTML? So XML is used for storing data and data communication. So as I said, inter-system communication standard, and HTML is used for display. So whatever you see on the web is something that is, you have a HTML page, you have coded it in HTML format, and it's used for displaying it. XML uses user-defined tags. HTML has its own predefined tags. So when you define your XML, it's a user-defined XML. As I said, today I might have a service which is taking employee ID and employee name, which is like user-defined, which is not predefined. Whereas when you use HTML, HTML is nothing but it has to get parsed into, or it has to get passed into a page which is being visualized by clients. So that's why you have a predefined tags. You cannot have anything, you cannot put something of your own, or if you put your own tags, it would show up an error. So it's validated. Reason being, you have to compile it or you have to run through to show it as a view or to show it as a HTML page to the clients. There's an interpreter which has to understand what you're trying to do. So it's predefined tags. XML is case sensitive and HTML is case insensitive. In XML, it is mandatory to close all the tags. So you cannot keep any tags open. So we'll talk about the tags once you see the format of the XMLs. But basically, if you have every property or every data that you want to send out will be enclosed in a tag, you'll have to ensure the tag is closed. Say, for example, employee ID, right? Employee ID will have an opening tag and it will have an employee ID as a value, and you will have to close the tag. You will have to ensure that employee ID tag is closed right after the value. In HTML, it's not mandatory to close the tags all the time. XML is dynamic because it is used to transport data. HTML is static because it is used to display data. So basically, when I say it's dynamic, it's extensible. So tomorrow you could change it, you could change the format, or you could add few more elements or few more tags or add some attributes. So it's pretty dynamic, could change it. Whereas HTML is aligned to a proper predefined tags and you can't change data or you cannot add some tags, additional tags of your own. XML preserves white space and HTML does not preserve white space. So what are the rules? Let's talk about XML rules. XML considers white space as the actual data. So whatever you're sending data through XML, so imagine you're sending data between two systems, right? So space is also a character when it comes to XML. So suppose you want to send some data that is client is typing. So of course you need to have space sent as well. You cannot have space ignored. It's actual data between two systems, communication between two systems. And since space is a valid data, it's been considered as data by XML. Ordering and nesting of XML document should be proper. As I said, you have to ensure that once you open a tag, you have to close it. There could be nesting. So there could be a tag which says employee, and within employee tag, you might have employee ID tag and you might have employee name tag. And once you have this employee ID and employee name tag, you have to ensure that you close the employee tag. So that's nesting. So you're nesting ID and name within employee tag. So yeah, this might be really confusing at this point if you have no idea about what the structure of XML is all about. But don't worry, in the coming slides we have examples and it's pretty straightforward. XML tags are case sensitive. Every opening tag must have a close tag, else XML will not correctly function. What does an XML file consist of? It has one root element, that is one tag which encloses the remaining tags. So it has one root element within which the entire content would be. And each element consists of start tag, content tag, and end tag. So there is one of the components of XML is nothing but element. Within an element, you would again have some content expressed in form of element again, which will have start tag, content tag again, and end tag. This is about nesting it. We'll see in the example, which is pretty much like readable format. XML tags are case sensitive. Opening and closing tags should be exactly the same without any difference in the case. So you have to ensure that it's been enclosed with the same case as it was started off. This is an XML. So the first thing that you see is nothing but XML declaration. The first line that you see here rather is nothing but XML declaration or prologue. So this is nothing but kind of saying what the XML is or the format in which it is encoded. Here you could have your DTDs, which we'll see in the coming slides, but it's a kind of summarizing your XML, what the XML is all about. That's your declaration or prologue, and that's mandatory. If you don't put it, it would throw you an error. Then comes the student tag, which is user defined. You could imagine this as a user defined XML, right? And you could imagine this as data being, or you could have a service, say, for example, which is doing something with this data, maybe inserting into a database, right? So you could imagine this being sent from client, or you have a web page, say for example, wherein you enter first name, last name, and email address of a student, and say for example that comes to a server and it's loaded into your database. So the root element of the document is nothing but student here. You can see a student tag, and as you can see here, it's an element